Oh, Oscar, there's some viewers.
Oh God.
I thought we'd lost them all to that muscly fella. Well, thank goodness for that. Come, join us. We're still working. Why don't our YouTube friends stand over there and get our good side? There we go, that's better. A bit slimmer this way. So, we're back in the countryside. It's a little bit scary for poor Oscar here. He's never been in the countryside before, being a town folk. Apparently there's some wild dogs running loose, so a little bit scared of that. We're having to keep an eye out. Apparently the police have said they've got no leads, so we're going to have to be careful. So we thought it'd be a good idea to do a completely comprehensive testing video on the EVSE chargers, because I feel like we've done a lot of videos testing them, but maybe we've not been specific enough or whatever, because we've had quite a few comments and I've had quite a few messages on Instagram especially asking, can we do a video explaining exactly the ins and outs of testing them? Because to be honest with you, they're really easy. Installing these chargers is stupidly easy, wiring them is stupidly easy, testing them is very easy as well. But there's a few little bits and pieces which make them slightly different. So currently it's isolated at the consumer unit, and I'll show you how we'd go about testing these things. Okay, so imagine you've just wired it up. You've managed to make it look like this with a huge excess of silicon. And now we'll just drop the cables out and we're going to do our first test, which will be insulation resistance, also known as the resistance of the insulation test, or in French, the résistance of the insulation. Okay, so we're going to go to the other side of the cable, which is over by the consumer unit. Now, Oscar actually has wired this consumer unit, and I think he's done a pretty excellent job. It's his first ever one, and I told him my tip to getting a consumer unit spot on. A lot of people have asked for my tip. My tip is cranberries. If you want to get your consumer units absolutely, you want to get cranberries involved. I find like just it soothes you, it softens the cable, gets it spot on. I need to get just the right amount so we don't get copyright. And you'll find that will get the cables just right, just the right level of softness to get the swoops into the cables, and just helps you keep your focus. But anyway, back to testing. So we've disconnected it the other side. We're going to set our multimeter to insulation resistance. That's the one. And we're going to set it to 500 volts, which it is set to. With our fancy schmancy meter, it will actually do a lot of the cross checks for us. So we only need to do the one position. So we want to be looking for over 999 mega ohms. Beautiful. And we'll just spin it around and do that again. Lovely stuff. So we have the insulation resistance that we are after. Put your test meter on your testing pole. Then what we're going to do is we're going to go back to the other end of the cable, which conveniently is only right here. Sorry, my YouTube friends, would you mind just standing, keeping your distance? Thank you very much. You need to take your test leads off of your apprentice. Then what we're going to do is we're going to zero the leads out. Do you remember the setting we put it to? You want a low resistance ohm meter, or in other words, continuity. And we want to calibrate it. That's the one. So we've zeroed the leads because we don't want to add the resistance of the cables into the resistance of the measurement. So now we're going to test between R1, also known as live, and R2, also known as earth or CPC. So we're going to get that and put these little probe things back on, and we're going to go put the leads back on your apprentice, hand them into his hand, and then we walk through here. Make sure you have your man bag at the ready. Okay. after you. It's fantastic. The new testers, you don't have to do anything. You just tell it what to do. You put that one onto the line, and we're going to remove any parallel paths in this test. And oh, sorry, we need a crocodile clip. Can I just grab a crocodile clip? In the meantime, I'll get this ready. So this is our EVSE tester. So this basically will talk to the pilot function of the actual electric car charger. It will simulate the pilot feature or whatever of the car, but we'll go into that into more detail later. So we'll connect that onto the earth, that onto there. We've already zeroed it out, and now we've tested it apart, and it's over series, out of range. Well, that's not right, is it? Oh, sorry, it's because it's set to R1 plus Rn. That's no good. R1 plus R2. There we go. Now we'll quickly zero that out again. Okay, we'll just remove 0.01 of our reading. So that is 0.09. Great. So now we'll stick that back in. And that is ready to talk out again. So now what we're going to do is I'm going to go back over to the car charger. Watch your head. Going to remove this. Can you get the torque screwdriver, please? How have you done that and not me? Right, I want to set this to the required torque setting, which I have. Oh, snapped it. Who did that, I wonder? This one should do it. Great. The thing is with these, you don't want to over tighten them because it's only going onto a little soldered circuit board. You can quite easily over tighten it and just snap them. So now that is all torqued up. So it's time for some live testing. Now, you don't need to do ZS if you don't want to. I know some registration bodies, such as the NIC, kind of leaning against ZS nowadays because they're trying to minimise live work. So what you can do is obviously get your ZE, your external impedance, and add that onto your R1, R2, and that will equal the same result. That would equal your ZS, your system impedance. But for the sake of instruction, we're going to do an actual measured ZS value, just so that you can see how to do it. But ordinarily, I probably wouldn't do a ZS. I've got my R1 plus R2, I've got my ZE. Sometimes I might choose to do an R1 plus Rn as well, just so I can compare the values, because all the cables are the same size. I'm not going to do that in this instance because there's only two connections and I can physically feel that they are both tight. I don't need to worry too much about that. So, great. See you shortly. Okay, so this is our ZE test. So as we're going to mention on the minute in the drawing that we're going to very scantily draw, this is measuring the external impedance of the system. So we're going to set to loop, which on some testers it's known as no trip. You get your crocodile Dundee clip, call that a clip. And then we're going to, on most testers you don't need a neutral. On this tester it does ask you for the neutral to be connected. So it's a live test with the main switch off for safety, because we have the main earth will be disconnected to remove any parallel paths. Okay, let's get that little bit of whatever off of there. So 0.20 ohms, and that is how you take a ZE test. Welcome to Cory's classroom. Okay, so today in Cory's classroom, what are we doing, Oscar?
Learning about ZS.
We're learning about ZS. That's exactly what we're learning about. So we're going to draw. Oh, I'm a terrible drawer, by the way, shocking drawer. But you know, what's drawn in the back of a van stays in the back of a van. So we're going to draw a consumer unit right here. This is a Hager brand consumer unit, not sponsored, but if you want to, hit me up. This is a Hager brand consumer unit. Actually, no, this is a Schneider consumer unit that we're drawing here. So this is a lovely Schneider consumer unit. And we have here our circuit breaker. Just for ease, we're going to cut out the main switch and all the rest of it. All right, so here is our circuit breaker right there. And we have coming in, let's draw at the end of our street, what's that? It's a supply transformer earthed into the ground. And we have some overhead power lines coming in. Boom, through our main fuse and all the rest of it. Forget about all that gubbins. Coming into our consumer unit and then out of the consumer unit to some sort of appliance. Let's say it's a metal clad light switch. That's a nice easy one to draw, yeah? So you've got a metal clad light switch. Now obviously you'd have all the circuitry, boom, 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 from there, but all we're worried about is the line and the earth, okay? So we have our line coming in, and then this metal is actually earthed. So this earth runs back to the consumer unit, or ultimately to a main earthing terminal, an MET. So that MET will connect back to the earth for the transformer, whether that's via TN system, PME, TT, whatever. For ease of drawing, because I'm not a very good drawer, we're going to do it as a TT system. So it's going to come out of the main earthing terminal into an earth rod, okay? So that is a potential fault loop path, I guess you could say. But this conductor here, never live. It's not a live conductor. This is also known as our R2. This one here, known as R1, or line. We also have our RN, which is neutral, but we're not worried about that in this particular circumstance. So we have, if you remember, R1 and plus R2, which was where we took the resistance of this length of cable here, plus the resistance of this length of cable here. And that gave us a reading, didn't it? But then we also did another test, which we just did, which was called ZE, which is our external impedance. And what we were measuring there was effectively the impedance of that conductor plus the resistivity going back again through the earth. So you actually would have a kind of loop of sorts in a fault scenario. So let's create a fault scenario. Let's say this metal clad switch, oh no, is somehow at fault. If you actually want to see a decent drawing on this, go on like a John Ward video or something. Feel free to skip this and go to a John Ward video. This is for Oscar, but I thought we might as well film it. So now your current is going to be going this way. Boom, 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 boom. Oh no, it's going to this metal box here. Well, if I touch this, actually, we're not worrying about that right now. We're worrying about the earth fault loop, okay? Stop distracting me. So now it's going down there. Boom, 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 down the R2, down the earth, underground, up the transformer. Whoa, round. And all of a sudden, we have an earth fault loop. So when we do earth fault loop impedance, fault loop impedance, also known as ZS, that is what we are measuring. We are measuring that full loop. So it's actually split into two separate parts. You have ZE and you have R1 plus R2. They are the components that make up our earth fault loop. So we have options there basically. We can either calculate our ZS by taking that reading, and adding them together, because basically ZS equals R1 plus R2 plus ZE. Probably the other way around, don't think it matters. So that is equal to that. You can't do it in reverse though. It's not advisable, for reasons we won't go into today. It's not advisable to calculate your R1, R2 by removing your ZE. But it's perfectly acceptable to calculate your ZS by adding your ZE plus R1, R2. And you want that measurement to be as low as possible, according to the breaker size, because the lower the current, sorry, the lower the resistance, the higher the current will be. So basically the faster disconnection time will be achieved, faster that them fuses will disconnect, cutting the power, cutting that fault loop. Does that make sense?
Yeah.
Are you sure?
Yeah.
Okay, does that make sense, Mr. Cameraman? Does that make sense, Mr. YouTube? Mrs. YouTube? Whatever YouTube? Now, I absolutely by no means claim to be an electrical teacher or expert or whatever. There are people that are watching this that will be far, far more competent. So if you have any comments about this or about the fault loop or whatever, check out, John Ward does an awesome video in it, which I think we'll try and leave in the description below. Or if anyone has any other comments or whatever, I'm open to learn. So just hit me up on Instagram. Okay, moving on. So as you've seen in the Cory's Classroom segment, we can calculate our ZS. We can take that by calculation with our ZE plus our R1, R2 reading that we've just taken, but we can also take a measurement as well. I'm taking my life into my hands because I've lost that clip. So we're going to set our machine to ZS, or earth fault loop impedance. We're going to take a test, and we'll record that reading. So, I mean, that's actually exactly what you would expect, because we took an R1, R2 of about 0.09 or 0.10. Sorry, the world's loudest plane is flying over again, which you probably recognised from the other video. So we had a R1, R2 of about 0.09 to 0.10, and we've got a ZE of 0.20. So that plus that, we'd expect to get 0.3. So that's actually perfect. Oh my goodness, I think we're being invaded. Right, it's probably all them French jokes that I've made. They're coming to get us. So that, my friends, compadres, as Pablo would probably say, is how you would do a test on the actual wiring. So we've got our insulation resistance, ZS, R1, R2, ZE, we've got our PEFC, PFCC, also known as our potential fault currents. And now what we'll do is we'll get the charger unit on itself, we'll get that set up, which you can watch another video on how to actually set that up. And what we're going to do is we're going to plug in our EVSE tester and show you the kind of little bits and tricks and nuances that come with doing EVSE testing. Okay, so I've got my Marks and Spencer's chewing gum in, spearmint, because 2 of them in fact, because I don't want to give off the impression that I'm not from Cambridge. So the EV is all set up. So remember, this is not an installation instructional video, this is purely testing. So we've done our insulation resistance, we've done our R1, R2, we've done our ZE, our ZS, we've gone through the details of that. Now, on to one of our final live checks, which is, on an EV, we have something which basically this this fancy schmancy charger does for us. So we're going to set these to the different settings, and this is going to basically simulate the pilot of the, how can I put that better? This is going to simulate the brain of the car. So this is going to ask it to do different things and create different fault scenarios, ask for a charge, and it's, I just want to see the pilot, I want to see the actual charger react to that. So right now in A, I want to make sure that this is in idle state. So checking the charger, it's idle, it's monitoring the power coming into the house, 200 watts, great. So now I'm going to set it to B. There we go, so I want to see that the EV is detected, but it's not charging. So it's detected the EV, but it's not charging. So that's good, that's grand. So now we're going to go to D, EV is charged. So we want to see that it's finished to charge. Ventilation, I think that is actually doing that because I went through B. So EV is finished charge. And now I want to create a pilot error, which is that one there, pilot problem. Great. So now what we're going to do, we're going to give those a tick. So those are all happy, happy clappy. We're going to do an RCD test. So what I do is, I set my tester, my RCD tester, which is about to run out of battery, selectivity to G. I want to test it as a type A RCD, 30 milliamp, 61008 or 61009. And then we will get this thing ready. Charging, great. We're going to test. So we want to see exactly the same test results on here as we would any other RCD. So at 1 times, which is 30 milliamps, we want to see it trip within 300 milliseconds. Oops. There we go, so tripped within 300 milliseconds. So we reset that. And at 5 times, 150 milliamps, we want to see it trip within 40 milliseconds. So it takes a little while. There we go, 107 milliseconds. So to reset the Zappi, what we do is we hold down the little pizza box for 3 seconds. Then that will carry on the test. It's going to test at 150 milliamps now, or 5 times the rated current. That's tripped in 20 milliseconds, which is spot on. That's what we wanted. So we'll reset that. So what we're doing is we're testing at both ends of the sine wave. We're testing on the positive half cycle and at the negative half cycle. So that is 180 degrees and 0 degrees basically. Hence why there's 2 times 1 tests and 2 times 5 tests and 2.5 tests, 2 I delta N tests, etc., etc. Great, so that has passed. We're going to now trip it. We're going to now inject 15 milliamps of fault current, and we want to see that it doesn't trip, because obviously that's half the rated value of the RCD. So on the positive half cycle, let's see, no trip. Great, over 300 milliseconds, and again on the negative half cycle, over 300 milliseconds. And now what it's going to do is it's going to do a ramp test up to, there we go, 18 milliamps. So that's fairly soon, but still not too bad. It's a little bit sensitive, isn't it? But the ramp test you don't have to do, that's just something that this tester does to complete the test. So that is how you test the RCDs on, that is how you test the RCDs on a EVSE car charger. So as you can see, there's not that much complication really. They're super straightforward circuit-wise and things to do. The one thing we do have to do is, well, actually no, we'll leave that for the other video, because we're sort of shooting 2 videos in one today, doing the install and the testing. But they're really straightforward. I have a lot of people asking me, could I do the course? Do you think it'd be hard? I'll be honest, most competent electricians will be absolutely fine doing EV. It's not a difficult thing to get into. The actual course, it's not so much the installation and the testing, it's more the paperwork and statutes and legislation and things around that, like notifying the DNO, the OLEV grants and the OLEV office and that kind of thing. That's probably more complicated than the actual installation of the charger in itself. We're working with a couple of different workflow management systems at the minute, who I won't mention yet, I don't know if perhaps Jordan will mention them at some point, but we're trying out a few different things to try and make that process of doing DNO notifications and things a little bit simpler. But in terms of the actual charge testing, that is it. So pretty straightforward. So if you've got any questions at all, just give us a shout, me or Jordan, on Instagram or in the comments below. We'd be more than happy to help. If you enjoy the video, feel free to give us a thumbs up. It's always very useful and friendly. If you really hated the video, give us a thumbs down and don't watch us anymore. I'm sorry that we've upset you. You should probably get a weighted blanket and chill out a little bit, you know. Weighted blanket, koala, hit it up, link below. Great stuff. Okay, lots of love. Take care and stay safe, everybody. Oscar, you're going to give him a little bit of love?
See you later.